Hello, my name is Ang Lee. I'm going to present our research titled GestureExplorer, Immersive Visualization and Exploration of gesture data. Our research is a result of the collaboration between Monash University, the University of Queensland, as well as the University of Canterbury.
GestureExplorer is a virtual reality tool for exploring gesture data in 3D space. It supports spatial understanding by representing gestures and 3D skeletons overlaid with motion trajectories. Along with multiple 3D visualizations and coordinated 2D views, GestureExplorer turns the surrounding immersive space into a part of the analytical process for better understanding of gesture data. GestureExplorer is primarily designed to support the analytic requirements of gesture elicitation studies. This type of studies collects and analyzes gestures proposed by end users, extracting common patterns to inform future gesture designs. As a result, massive computational supports are required to identify potential gesture patterns or clusters in the dataset. Besides, it requires manual refinement of the identified patterns to improve the accuracy of them. Different views are also in demand for understanding gesture data. Though there have been prior works that attempt to facilitate this type of study, what differentiates our tool is that our use of spatial approach to better the understanding of gesture data. As such, we raised extra rationales from an immersive analytic perspective. First, we aim to exploit the surrounding space in an immersive environment to organize and analyze gesture data. Second, we provide multiple views and features that could be used in coordination for a better understanding of the gesture data. Lastly, we designed GestureExplorer based on Meissner's visual analytic framework as well as Schneidmann's mantra. Here is an overview of the features we implemented in GestureExplorer. Each of them can be mapped to an abstract visual analytic tasks as defined by Meissner. Using a combination of them allows users to have not only an overview of the dataset, but also a detailed understanding of data that is of interest when necessary. I would like to demonstrate GestureExplorer using a few scenarios in the context of a typical gesture elicitation study. In the start, users will need to have an overview of the entire dataset to identify potential gesture patterns. For this, we come up with spatial arrangements leveraging dimensional reduction algorithms such as PCA and MDS to help users observe the overall distribution of data, and also clustering algorithms such as K-Minx to generate the clusters. In this scenario, the user simply turns on the overview map and observes the distribution of the gestures on the spatial arrangement resulted from PCA, who roughly identifies 3 groups of gestures and thereby sets up a clustering session based on his observations. And as a result, they receive the following clusters. After the user identified the potential clusters, they will need to refine the clusters by finding and excluding outliers from them. To do this, we provide some other spatial arrangements such as the global, local, and the lineup arrangements. These arrangements encode the similarity of a gesture to the average value of its corresponding cluster into distance. For example, in this scenario, the user is using the local arrangement and viewing the distance between each gesture to the center of the cluster. The farther a gesture is from its cluster, the lower similarity it has with the other values in the cluster. The user can thereby mark them up as the potential outliers. Similarly, this could be done by the lineup arrangement, which organizes gestures in a row based on their similarity. The user could expect to find the least similar gestures at the end of the line. Now we have the outliers identified. The next thing to do is to make comparisons of them in order to determine if they should be excluded from their current cluster. GestureExplorer has multiple visualizations for users to identify the similarity and differences between gestures. The first way to do this is simply looking at the shape of the motion trajectories for any significant differences. The user can also pull out the small multiples of the gestures for the difference in their motion trains. To gain more details, animation could be played for the gestures, and if the animation is viewed together with small multiples, an overlaid animation will be also applied to the small multiples themselves. Users can also stack gestures together and turn on the heat map effect to highlight the similarity and difference among the motion trajectories. We blended the transparency of the trajectories, so the brighter an area is, the more frequent that area is visited by the trajectories. We also provide a filter feature that allows people to focus on motion of particular body parts that are of interest. Finally, after the outliers are confirmed, They could be simply excluded by initializing a new cluster. Notice that our tool is dynamically updated. The position of the gestures in the new cluster will be computed in real time. Lastly, I would like to highlight a very interesting feature we had in GestureExplorer, which is the Embodied search feature. This feature allows people to propose their own gestures simply using the two VR controllers, and using their proposals to fetch up similar gestures in the existing dataset to inform the popularity of their proposals. We evaluated GestureExplorer in 2 user studies. The first study validated its usability. We invited 9 academics in the field of immersive analytics, data visualization, and human-computer interaction. They experienced every feature implemented in GestureExplorer and provided valuable feedback through a semi-structured interview. Overall, we got quite positive feedback that the visualizations were intuitive and immersive, and our tool was entertaining to use. We were able to thereby improve existing features and introduce new ones based on their feedback. I recommend referring to our paper for more details about this study. The second study evaluated GestureExplorer's practical ability to facilitate the analysis process of gesture elicitation studies. We invited 10 participants and simulated a typical pattern analysis in the elicitation studies. We purposely mixed up 90 gestures that belong to 3 different gesture types and asked our participants to freely use our tool to identify the 3 patterns and thereby refine them. After this, we gathered participants' preferences via a UX questionnaire. We had a very interesting observation that our participants were able to complete the tasks using different analytical strategies. The first bunch of participants relied more on the different spatial arrangements in GestureExplorer in order to identify outliers and exclude them correspondingly. Another type of participants relied on the more detailed visualizations such as the trajectories and the animation. They made detailed comparisons between gestures and were also able to identify outliers and refine the clusters eventually. This confirms that GestureExplorer is a promising tool as it allows different approaches of analysis. The approaches are different in the procedures but are able to lead to the same outcome eventually. To wrap up, we presented GestureExplorer. This is, to our knowledge, the first visual analytic tool that enables complex and embodied analytics in the immersive environment for gesture data. We've gotten confirmations from domain experts and users that our tool is viable for the exploration and analysis of gesture data. For future works, we would like to make a comparison of GestureExplorer to its 2D counterparts to gain further insights, as well as to explore other data types with GestureExplorer. As there is a growing community in immersive analytics, we would like to share our tool with the community to provide insights for future research. Our tool is available via this QR code, and feel free to get a copy of it and try it yourself. Thank you very much.